Hey, good afternoon, everyone. Meteorologist Steve Caparata here from the WAFB First Alert Storm Center. Happy again to be back here doing Cap's Corner. Really excited about the guest we have to speak with us today. Dr. Phil Klossbach. I'll go ahead and bring him in. Dr. Phil Klossbach, researcher at Colorado State University. A name you've probably heard for a number of years now, best known for doing these seasonal hurricane forecasts. So first off, Dr. Klossbach, thanks for being here today.
Yeah, thanks so much for having me, Steve. Looking forward to chatting with you today.
All right, so let's start with the easy stuff. First off, tell us a little bit about your background, how you got into meteorology, maybe where you're even from. And I think people always find it interesting. There's a legacy here that I think we'll get into a little bit, but you're based in Colorado. You work for Colorado State University, but you're doing this hurricane research. So maybe tell us a little bit about your background and how you got to where you are now.
Yeah, so I was born and raised in Massachusetts, in Plymouth, so right on the water. When I was a little kid, I was always obsessed with the weather. I just remember, I guess I've heard someone say you're born with a thermometer in your mouth. That was kind of me. I was just always kind of born with that defective weather gene, just obsessed by the weather, trying to figure out, basically growing up in New England, it was a lot about winter storms, we're getting nor'easters and how much snow we were going to get, or if we were going to get rain, living on the coast. But we had Hurricane Gloria go through, and it made landfall in Connecticut, but it brought some pretty significant impacts in eastern Massachusetts, where I was living then, back in 1985. And that's really kind of catalyzed my interest in hurricanes. We also had Hurricane Bob go through a closer hit. It went through Rhode Island into Massachusetts in 1991. So it's really kind of what spurred me to look more at hurricanes. And so I did my undergraduate degree in Massachusetts at Bridgewater State College, and then I was looking about going to grad schools, and I'd always been fascinated by seasonal hurricane prediction. I had actually done, when I was an undergrad, I did a lot of projects on that topic, and so I applied to go to grad school at Colorado State University because that's where Dr. Bill Gray was working at the time. He was a renowned professor, and he had started these seasonal forecasts back in the early 1980s. And when he gave me a call and said he'd love to have me come out and go to grad school at CSU, I was very, very excited. And CSU hasn't been able to get rid of me since. It's been almost 20 years that I've been working at Colorado State now.
All right, so I might have people a little confused because when I bring you up full screen, I have you at Colorado State University. But when I was speaking with you leading up to our talk today, you tell me you actually live in California, right? So kind of explain how that works out.
Yeah, so I live in Walnut Creek, California, so in the East Bay of California. I moved here about 6 years ago. My wife got a great job opportunity out here in the Bay Area, so we moved out here for that. And I've been working remotely for Colorado State for almost 10 years now. So I do a lot of research. As long as I have a good internet connection, I can do pretty much what I need to do from hopefully just about anywhere in the world.
I had to look it up when you sent me Walnut Creek this morning, but in the Bay Area, so I'm kind of jealous. Just a beautiful part of the country. By the way, down here in South Louisiana, Phil, today, we're kind of having a California kind of day. It was 60 degrees at lunchtime, sunshine, just beautiful weather. All right, let's get to what everybody, I think, that's probably joining us is probably most interested in today. You do these seasonal hurricane forecasts, and your forecast for this year is calling for an above-average season in the Atlantic. So tell us a little bit about how you arrived at that forecast.
Yeah, so our group at Colorado State, the Tropical Meteorology Project is what we're known as. Dr. Bill Gray founded that project. He did a tremendous amount of research in hurricanes. He's best known for the seasonal hurricane forecasts. We did a lot of other research in tropical cyclone genesis, structure, intensity change, and just probably one of the biggest names in tropical meteorology research that's ever lived. But he started the seasonal forecasts in 1984, and our group at CSU has been doing them every year since that time. If you go to our website, you can see all the different forecasts every year going back to the early 1980s. I used to tell Dr. Gray when he started these seasonal forecasts, I was starting nursery school. But yeah, so our forecast for 2020 is for an above average hurricane season. we're calling for a total of 16 named storms. Of those 16, 8 becoming hurricanes. And of those 8, 4 becoming major Category 3, 4, 5 hurricanes. Those are hurricanes with winds of 111 miles per hour or greater. Now that compares to the long-term average, which is about 12 storms, 6 hurricanes, and 3 major hurricanes. So not tremendously above normal, but a little bit more normal than what we get in an average overall hurricane season.
All right, so I pulled up the forecast numbers. Now, what I'd like you to do, as maybe as simply as you can, is walk people through how, and I know you use different variables depending on which forecast you're creating. So you do a number of these throughout the year. Your next update in June, correct? Early June?
That's correct. We put out our next forecast in early June, and then we do 2 additional updates in early July and early August. And we update the forecast because, kind of like your weather forecast for 1 week from now is going to have less skill than your weather forecast for tomorrow. As you get closer to the events that you're trying to predict, the forecast skill goes up. And hurricane season starts June the 1st, but about 95% of all your major hurricane activity occurs after the 1st of August. And those major hurricanes are winds of 111 miles per hour or greater. And while those only make up about a quarter of all the storms that form in any year, when you take these storms and you look at how much damage they've done historically, they do about 80 to 85% of the damage. So most of the damaging hurricanes come during the 3-month period from August to September and October. So we do one final update in early August because that's when our forecasts have the highest levels of skill. And also, if we realize we had really messed up the forecast earlier, it gives us one last chance at a mulligan to basically get it right before the season really ramps up.
So, Phil, I'm going to pull up now in your April forecast. This is going to be, for some of the kids, this might be a little bit much to absorb, but I know some of the adults, some of the older kids want to know more about it. I've got your map up from your forecast package showing your April predictors, what you guys look at to help you arrive at your April forecast. So walk us through those three main April predictors that you use.
Yeah, so I'll probably take even a step back from just dialing in on those. And so basically, the way that we do our seasonal forecasts is we use a lot of historical weather and climate data. So if you go back, we have historical hurricane data that goes all the way back to the 1850s. But as you go back in time, the data gets more questionable just because we didn't have satellite data to observe hurricanes in the central and eastern Atlantic prior to the mid-1960s, and we didn't even have planes flying out into these storms prior to the mid-1940s. So our ability to observe the hurricanes has certainly improved with time, but we have reasonably good data going back to around 1950 or so for hurricane numbers. We also have reasonably good data for things like water temperatures, pressures, and winds, going back to 1950. So what we try to look for is basically precursor signals. So if hurricane activity in a season were completely random, you would basically see no relationship between large-scale factors and hurricane activity. Basically, it's just like throwing darts at a board. There's nothing there. But if you look at, say, 5 or 10 active seasons and 5 or 10 inactive seasons, you'll start to see distinct sets of climate patterns. And so one of the big factors that we look for every year is El Nino. El Nino is warmer than normal water in the central and eastern tropical Pacific. And so the way that impacts hurricanes, which obviously are in the Atlantic hundreds of miles away, is that when you have an El Nino, it increases upper level winds in the Atlantic. It tends to tear apart hurricanes, especially in the Caribbean, extending out into the tropical Atlantic. So for this year, we don't think we're going to have El Nino conditions. We think the odds of that are unlikely. So that's one of the reasons why we have a somewhat higher than normal forecast. And then one of the predictors that we use with our April forecast is looking at basically the conditions over the tropical Pacific Ocean and the subtropical Pacific Ocean, trying to assess what the chances of El Nino are for the upcoming season. We also have in our seasonal forecast, we have 2 predictors over the Atlantic. In the Atlantic basin, warmer than normal water provides more. When you have upper level winds out of the east that tends to counteract what they normally blow out of the west. It weakens them, so you get less overall this what's known as vertical shear. So you have less of that those winds trying to tear apart the hurricane, and consequently the hurricane's better able to develop and to intensify.
So, Phil, I'm going to jump in here because I know you can't see everything I'm showing, but I've got your April predictor graphic up. So you just described, I think, predictors 1 and 2 on this graphic that I have up right now. So for the kids and people watching at home, that box that's number 1, that's where they look for the sea surface temperatures, the water temperatures, January through March, as you see noted on the graphic. And then Phil was talking about the upper level winds. That's box number 2 on this graphic that we're looking at right now. And then I think people might be interested, Phil, the third box that you have is over there, the Coral Sea. So how did you figure out, or why is there a connection between what happens all the way over there and what we get in terms of hurricane activity in the Atlantic?
Yeah, so what happens is that these are phenomena known as teleconnections. And so basically what that means is that when the weather and climate or the water temperatures behave a certain way in one part of the globe, it then impacts kind of how the whole large-scale climate system works. It then can impact weather patterns months later in another part of the world. And so in this case, what we find is that when the waters there are warmer than normal, that tends to be associated with effectively patterns that tend to effectively inhibit or prevent El Niños from developing, or that tend to basically kind of basically, if you have an El Nino, weaken the El Nino conditions and tend to take you more towards neutral or La Nina conditions. One thing when we do these kinds of statistical modeling is that you tend to have fairly high correlations between, say, the water temperatures in the Atlantic and the wind shear in the Atlantic. And so when you're doing a statistical model, you're trying to kind of find parameters that correlate with hurricane activity but don't correlate really strongly with each other. And so that's one of the reasons when our statistical model, you will see that all the regions don't necessarily overlap. You'll see conditions in certain areas, and then you may see another box somewhere fairly far removed. Another thing I want to point out too is that the predictors sometimes are more fairly far removed early in the season, so maybe with like our April outlook, whereas by August the predictors tend to be more closely located in the tropical Atlantic, because then you're not looking at kind of like what happens in the Pacific Ocean and impacting the Atlantic. You're looking at what the Atlantic itself is doing, because the teleconnections aren't as important during the peak of the season as they are, say, months before.
All right, I'm going to come back because you also brought up El Nino and La Nina a little bit earlier in your discussion. So right now, Phil, I've got up the graphic that shows the sea surface temperature anomaly. So that's the difference from normal out over the Pacific Ocean that you included in your outlook as of late March. As we look at this graphic, and for the people watching at home, there's kind of a lot of yellow and orange centered near the equator. So right now, it's actually much of the tropical Pacific a little warmer than normal. But the thinking is, right, that that's going to change in the coming months.
That's correct. So what the graphic is you're showing is sea surface temperature. So that's what the ocean temperature is like right near the surface. And the anomaly, again, is the difference from average. So where you see yellows and reds, that's warmer than normal water. And if you see blues, that's colder than normal water. But if you look beneath the surface, so at the subsurface, so below the surface of the ocean, the waters are actually they're actually a decent bit colder. And so with time, when you get these fairly strong winds that tend to kind of mix and churn up the ocean, that colder water is likely to come up towards the surface. And that's one of the reasons why we think this El Nino, or it's not officially El Nino, but kind of a little bit warmer than normal conditions in the tropical Pacific are likely to diminish fairly quickly over the next couple of months. Is that basically beneath the surface of the ocean, you see the surface is still kind of warm, but beneath the surface, it's actually quite a bit cooler. So we think the transition away from kind of what we call warm neutral, so not quite El Nino, but a little bit warmer than normal, are likely to diminish.
Yeah, let me break it down simply for the kids that might be watching it at home. So as we look at these water temperatures out in the Pacific, there are really kind of 3 states that we look at, and it's called ENSO, the El Nino Southern Oscillation. So when things are kind of about average, we call it neutral. When the water in the Pacific is warmer than normal, especially it's a certain threshold, but when it gets a good bit warmer than normal, we call it an El Nino. When we have El Nino, typically that might result in reduced hurricane activity in the Atlantic. When we get it a good bit cooler than usual, that's a La Nina, and we find that sometimes hurricane activity in the Atlantic increases. So bottom line, Phil, right, is that we're trending a little closer to La Nina, or at least the thinking is trending that way into the summer months.
Yes, that's correct. And the differences between El Nino and La Nina, the temperature difference isn't that much. So basically, if you look at the temperatures and you say, okay, if the water is 1 degree Fahrenheit warmer than normal, which, whether the water is 82 or 83 degrees, if you were out swimming, you wouldn't necessarily even notice the difference. 1 degree Fahrenheit warmer than normal is enough to classify it as an El Nino, and a strong El Nino is about 3 degrees Fahrenheit warmer than normal, and a strong La Nina would be 3 degrees Fahrenheit cooler than normal. So it's a very small difference in water temperatures, but it makes a big difference in how the atmosphere then responds, and that's what we're looking at for the Atlantic hurricane season. Is water temperatures in the Pacific Ocean then change the whole circulation of the climate, circulation of the atmosphere, to then change how the Atlantic then responds, and that's what knocks down or increases the level of hurricane activity. And that's one of the discovery of El Nino's impacts on Atlantic hurricanes is really what got Bill Gray starting to do the seasonal hurricane forecasts back in 1984.
All right, so now I'm going to kind of get you to what I'm sure you're used to this by now, but it's something I get. We talk about these seasonal hurricane forecasts, but ultimately what most people want to know is a hurricane going to hit my area? That's what everybody wants to know, right? That's just about impossible to determine in advance, but you guys do some probabilities of particular areas being hit. So talk a little bit about what you're seeing for the upcoming season in terms of the landfall probabilities.
Yeah, and so basically the way that these seasonal forecasts have skill at being able to predict basin-wide activity is because if overall the tropical environment is more conducive for hurricanes, you're likely to see more overall hurricanes forming in that environment. When it comes to landfalls, however, it's dictated by how conducive the environment is in the tropics, but it's also driven by mid-latitude weather patterns that basically steer the storms to cause them to either, say, track all the way across the Atlantic into the Gulf of Mexico, or to cause them to basically recurve and head out to sea and not impact anyone significantly. And being able to predict those weather patterns in the middle latitudes has very low levels of skill, even, say, 2 weeks out. So unfortunately, I know people think it's a cop-out because they say, well, if you can't say where the storm is going to make landfall, that's not really helpful for me. And unfortunately, you can't say where these storms are going to strike, but you can have, the reason that we do probabilities of landfall is because in general, more active seasons do have more landfalling hurricanes. Now, there's plenty of examples of quiet seasons or seasons with below normal hurricane activity that still had significant landfalls. A couple of prime examples of that would be 1992. We were doing seasonal forecasting in 92 at CSU. Dr. Gray had a great forecast that year of only one major hurricane. We only had one major hurricane. It was the first storm the Hurricane Center named that year. It formed in late August. So you think, okay, late August, we've only had one storm, but that was Hurricane Andrew, which obviously was devastating in parts of South Florida. Also, 1965, we only had one major hurricane that year, but it was Hurricane Betsy, which was a very significant hurricane in southeast Louisiana, in south central Louisiana. So consequently, we say that in general, more active seasons have more landfalling hurricanes, but when it comes to preparation for hurricane season, we need to prepare the same every hurricane season, because it just obviously takes that one hurricane making landfall near you to make it an active season.
I'm glad you brought that up, and those two examples you used are the ones we often use around here, because not only in Andrew, of course, it was a Cat 5 when it hit South Florida, but then came into Louisiana as a Category 3, did a lot of damage where I am around the Baton Rouge area, and Betsy is another just historic benchmark storm for this area, even as far inland as Baton Rouge and farther inland for big impacts. So it does just take that one. All right, I'm going to ask you another question or two. Before I do, I'm going to encourage everybody that's watching, if you've got some questions for Dr. Klossbach, go ahead and feed them in the comments, and I'll start asking him those questions as well. So, we talked a little bit about those landfall probabilities. Can you talk a little bit about specifically the numbers on the major hurricane landfall probabilities for the United States and the Gulf Coast that you guys have calculated for the season?
Sure. I'm just pulling them up now. So if you see me looking down on the screen,
That's all right.
I'm
I'm
just
putting you on the spot. I know.
Okay, I don't have those numbers memorized. So basically, the way that we calculate these probabilities is we have basically the probabilities historically for hurricanes making landfall. So for major hurricanes for the entire U.S. coast, the average for the last century, so from 1900 to 1999, was 52%. So basically a 50-50 chance on average that a major hurricane is going to hit the U.S., just based on historical odds. This year, that probability is elevated. It's about 69%. Again, because we're predicting an above normal hurricane season. And if you look historically at landfalls, they're about evenly split between the Gulf Coast, so from Texas to just north of Tampa, and then the East Coast, so basically the rest of the coast, so from Tampa southward all the way up the East Coast to Maine. And so on average, it is about a 30% chance or a 3 in 10 chance that the Gulf Coast or the East Coast is hit by a hurricane each year, or by a major hurricane rather. This year, those probabilities are elevated. They're both about 45%, so just a little bit less than 50-50, that a major hurricane will make landfall. So again, these probabilities, as you get to a smaller and smaller section of coastline, do decrease, because obviously if a hurricane makes landfall on the Gulf Coast and it makes landfall in South Texas, if you're living in Louisiana, it might not cause you any impacts. But obviously, if there were a hurricane to make landfall in the Gulf and it made landfall in Louisiana, your colleagues in Texas might not have any impacts, but you would. So that's one of the things that we point out, is that obviously as you kind of go to a smaller and smaller chunk of the coastline, the odds of being significantly impacted do decrease. But obviously, if a hurricane makes landfall near you, it's a very active season. So that's what we try to highlight with these probabilities, is that, again, the odds are up a little bit this year because we're forecasting an above normal hurricane season. But the odds of any one spot along the coast being impacted in any one year are low, but never zero. And that's why we need to be prepared the same every year for hurricane season. Like I am in California, prepared for wildfire season and earthquake season out here.
We don't envy you on either one of those, I think. We always say that, at least with the hurricanes, we typically have a good bit of notice before something comes our way. I'm going to throw something else your way here, Phil. We talked a good bit about El Nino, La Nina, Pacific sea surface temperatures. You did talk a little bit about the Atlantic. I want to pull up the Atlantic, though. This is also a map you shared in your April forecast. So for the people watching at home, these again are sea surface temperature anomalies, the difference from normal. But what we're noting over a lot of the Atlantic is a lot of orange and red on that map. So a lot of the Atlantic is running warmer than normal. But Phil, here's one interesting point to me relative to our local area. As you look at the Gulf of Mexico, it's really red. It's really running above normal. But correct me if I'm wrong here. Most of the research has shown not much of a correlation between what's happening in the Gulf right now and how it plays out in hurricane season.
Yeah, that's correct. Gulf of Mexico water temperatures don't really correlate with overall hurricane activity in that part of the Atlantic like they do in other parts. And I think it's because if you look at Gulf of Mexico water temperatures, any year, they're always plenty warm to support nasty hurricanes. Water temperatures there are not really a limiting factor. So really what limits Gulf of Mexico storms in any year is basically getting a disturbance, so an unsettled weather area into the Gulf of Mexico. But you also need to have not too much of that vertical wind shear. So we talked a little bit about that earlier with El Nino and La Nina. If there's too strong of winds at upper levels, that can really tear apart anything that's trying to form there. And we also need to have enough moisture. Sometimes it can be kind of dry, and that really tends to choke apart any system that's trying to develop in the Gulf of Mexico. Another thing with that too, if you look at Gulf of Mexico water temperatures now, they're much warmer than normal, but that's not a guarantee that they're going to remain warmer than normal for the peak of the hurricane season. If a good strong front were to come through, you can cause quite a bit of mixing and cooling. Just a recent example of basically the opposite situation is if you looked in 2010, in March of 2010, it was one of the coldest Marches on record in the Gulf of Mexico. It was very cold in the Gulf in 2010. By June, the Gulf of Mexico water temperatures were the warmest on record for June. So these things can change. The Gulf of Mexico water temperatures can change fairly quickly. And so that's something else we want to pay attention to. But yes, right, if you look at overall activity levels, Gulf of Mexico water temperatures don't correlate much with Gulf of Mexico hurricanes. But if those water temperatures were to remain elevated and something were to develop in the Gulf, obviously that would potentially lead to a stronger overall storm, given that the water temperatures there are much warmer than normal.
All right, we've got a question in from 9-year-old Zane, and I don't know if this is in your wheelhouse, but I'll see what you can do with it, all right? So Zane wants to know, what is the most dangerous hurricane from the past?
Oh, man. Well, I think that's tough to answer. I mean, I think, honestly, one of the worst storms that I've seen play out in recent memory, I think, would just be last year with Hurricane Dorian. And the thing with Hurricane Dorian was obviously it was a very, very powerful hurricane, one of the strongest hurricanes on record. But not only was it really, really strong, it was very, very slow moving. And it tracked over the northwestern Bahamas, which are islands. They're small islands. So when hurricanes make landfall, they weaken very quickly because hurricanes live off of warm ocean water. So when they run out of that warm ocean water, they weaken. But because Dorian was over a fairly small landmass, it was able to keep tapping that warm ocean water that's near the Bahamas. And it weakened only very, very slowly. So the people in the northwestern Bahamas on Grand Bahama and Abaco basically were slammed by Category 5, so the highest level of winds, combined with very heavy rainfall, as well as very strong storm surge, which effectively is the rising of the ocean water. And that combination was, they had those horrible conditions for about 24 hours. So just absolutely inundated by that storm. So I would say Dorian, maybe not the worst hurricane we've ever experienced, but certainly one of the worst ones in recent memory, just in terms of the fact it was incredibly powerful and also very, very slow moving. But because it was over a small island, it was able to it slowly weakened, but it was able to maintain very powerful intensity for a day or more over the northwestern Bahamas.
For a tricky question, I think that was an awesome answer, and I agree with you. I can't imagine what those folks had to suffer through and deal with. It's so hard to even imagine a Category 5 for most of us, those impacts, but then imagine it crawling along and stalling like you talked about. That's a really good answer. Let's lighten it up a little bit here quickly, Phil. So you studied under Dr. Gray. I got to see him speak a number of times before he passed away, and he was a real character, right?
Yes, definitely. I have lots and lots of Bill Gray stories to tell. We actually, myself and 6 other of his PhD students published a paper, like a formal journal article paper on him a few years ago, and just all the different stories. And just, he was a brilliant scientist, but also just a larger than life person. He just had a huge personality, and he was about 6'5" and just loud, booming voice, and just a character, and just an all around great guy. He gave a toast at our wedding, and just a great guy. I just loved spending time with him, and certainly learned a tremendous amount from him. And certainly even just when we went through and cleared out his office after he passed away, just all the different stuff and memorabilia he had. He never threw anything away. So just an all around great guy, and certainly lucky to have had a chance to see him work with him for 15 years. And he passed away 4 years ago tomorrow, in April 16th, when he passed away in 2016.
Wow. He was an incredible scientist, too, as you mentioned. So it seems to me, from following you over the years, help me out here, I think there's some kind of tradition with the forecasts and donuts. Am I right?
Yes, that's correct. So I'm not sure the exact year that started, but so before the internet and everything being posted online, Bill Gray used to print out and then mail out forecasts to like 200 or 300 different media outlets, friends of his, each year. So the tradition was he would bring in donuts on forecast day. And so there's a forecast day donut tradition that's gone on for about, since I think the late 1980s is when we figured out it started. So we do continue that tradition with every forecast release. Unfortunately, my local donut shop is currently closed. Thanks to coronavirus. So my wife and I made pumpkin scones. So we have pumpkin scones on forecast day this year, but hopefully in early June, everything will be, at least that donut shop will be reopened, and we'll be able to reinstitute the donut tradition for the June seasonal forecast.
So let me make a suggestion. If this hurricane season ends up being not so bad, I know you're forecasting above average, but maybe the U.S. and the Caribbean escapes a major hit. You might want to keep that pumpkin scone tradition going forward if it works out, Might be good karma.
Good. Oh, yeah. So one thing I was going to ask, one thing I was going to address, because I'm guessing this question is on people's minds, is, why do you forecast hurricane activity in Colorado? because Colorado doesn't get hit by a lot of hurricanes. I can make a good forecast right now and say Colorado won't have any won't be hit by any hurricanes this year. And so the answer goes back to the mid 1950s when our department was getting underway. That Dr. Herbert Reel, who was a big-time hurricane researcher in the 50s, was asked to start a department. He was at the University of Chicago, which is still nowhere near hurricanes. But when he was asked to start the department, Bill Gray was finishing off his PhD at the time, and so he came out to Colorado State with Herbert Reel, and Herbert Reel was a big-time hurricane guy, and so Bill Gray was getting well-known in that field as well. So our department has always had a fairly robust hurricane focus. And the other answer is when people used to ask Bill Gray why he forecast hurricanes in Fort Collins, he used to always say it's because the storm surge can't get him at 5,000 feet.
That's a good answer. I do have another question coming in for you. I did this may be coming off of, I did a sort of an introduction to hurricanes lesson for kids a couple of weeks back here. And let's see, this is from Kyra. She might have been listening that day. Do you know of any hurricane season where we had to resort to the Greek alphabet?
Yes, in 2005, we had 28 named storms. So we did go well into the Greek alphabet that year. So that was the most storms on record that we've named in a single season. So a whopping 28 named storms. So we went well into the Greek alphabet that year because while there are 26 letters in the alphabet, I believe we went through, they don't do X, Y, Z, Q, and there's one other one, I believe. U, thank you. Yeah. So there's 21 letters. So once you get past 21 storms, you go into the Greek alphabet.
And that is, the names is one of the things we went over. I repeat that one to kids all the time. That's why I jumped right in there, Phil. But that 2005 season, for our younger kids that might be watching, not only was that historic overall in the Atlantic, it was historic for Louisiana. We not only had Hurricane Katrina, Category 3, which devastated New Orleans, Mississippi, much of southeast Louisiana. We had Hurricane Rita, another Category 3 that came into southwest Louisiana. And then there was kind of a forgotten hurricane earlier that season. I tell people all the time, its name was Cindy. That one came into southeast Louisiana as Category 1. So very active for Louisiana that particular year. We had 3 hurricane landfalls. It looks like I'm not seeing many questions coming in. I'm kind of surprised. So I'm going to hit you with a couple of lighter things before we wrap it up here, Phil. See if we can learn a little bit about Dr. Phil Klossbach. So number one, Dr. Phil, do you have a favorite sports team?
Yeah, so my favorite sports team would be the Boston Red Sox. I grew up on the East Coast, grew up in Massachusetts, so died in the wool Red Sox fan. 2004, watching them come back and beat the Yankees in an epic 7-game ALCS, and then to go on to beat the Cardinals. That was a very transformative experience for me. I had my Pedro Martinez Wheaties box next to me every game during that postseason. So so died in the wool Red Sox fan. That would be my favorite sports team. I'm hoping we'll be able to get the season started at some point, but we'll see.
What happened to your Boston accent? I don't hear it.
I never really had too much of a Boston accent. My parents were always trying to correct me from speaking with too much of a Boston accent. But if you put me with a bunch of my friends from back home, I definitely can slip into one pretty quickly.
All right, next question for you. What's your favorite TV show, if you have a favorite?
Oh, gosh. I generally watch sports. Back in the day, I really liked Seinfeld a lot. I love The Simpsons. Especially in grad school, The Simpsons really helped me through. I watched a lot of Simpsons in grad school. Sadly, now I'm getting old, so I think my favorite show, the show I watch every night now, is Jeopardy. So that's kind of dating me, huh?
All right, one more. Well, I got a couple more for you. What's your favorite food?
Oh, favorite food. Gosh. I'd say pizza. But when I do a ton of hiking, and when I'm hiking, it's a combination of animal crackers and M&Ms. That's a great hiking combination.
There you go. That's right up my alley right there. Speaking of which, you mentioned the hiking, and I saw this in your bio, and I think I've heard it before. You do a lot of hiking and mountain climbing, right? Tell folks about that.
Yeah, so I do. I'm happiest outside. In 2002 I thru hiked the Appalachian Trail, which runs from Georgia to Maine, and it's 2,800 miles. So Dr. Gray, when I defended my master's thesis that spring, and he said, well, if you want to go hike the Appalachian Trail, now's a good time to do it. So I went and did the Appalachian Trail, got off a couple times to help with the seasonal forecast that year. And then I've climbed all the 14,000 foot peaks in Colorado. There's 50, 54, 55, depending on which exact list you use. I've run a handful of marathons, a few ultra marathons, and just generally just like to be outside. And the East Bay is absolutely beautiful, especially right now. So it's a nice time to be able to at least explore some of the trails, the ones that are very, very close to me that I don't have to drive to, the ones we can hike to, because that's what they want us to do right now.
I love how he casually says, a handful of marathons, a couple of ultra marathons. Phil, I've been running in the mornings a good bit lately, and I'm struggling to do 2 to 3 miles regularly. I still marvel at you people who can do marathons and ultra marathons and climb 14,000 foot peaks.
Well, especially when I get to the longer distances, it's not all running. There's some walking involved. That's why I like doing long distances, because if you're running a short race, you have to run the whole thing. But if you're running a long race and you walk parts, and it's called strategic pacing.
All right, I'm going to remember that one, strategic pacing. All right, we did get one other question coming in. I don't want to leave anybody out. Let's see. So where'd it go? From Patrick. He's age 9.
Okay.
Dr. Klossbach, do you remember the hurricane names they used from the Greek alphabet?
Yeah, so let me double check, because there were a couple of storms that, so with the Hurricane Center at the end of each year, what they do is they go back and they look through, basically they look back through the hurricane season, and every now and then they will actually name a storm retroactively. So it won't actually get a name, it'll just get a number. But sometimes, so if you see 28 storms, there may not actually be 28 names. So they went through 6 names. There was one storm that didn't get named during the season, but they went back retroactively and said, oh, we think it actually was a tropical storm. So we went through 6 Greek names, so Alpha, Beta, Gamma, Delta, Epsilon, and Zeta. And Zeta we actually ended up going, the Zeta, I believe, actually lasted into January. So 2005 was a season that just seemingly never ended. And I think it's also, frankly, pretty remarkable that the W storm that year, so the 21st storm, Wilma, was actually retired. You would normally think something if your W storm be super late in the season and probably not very strong, but Wilma was an incredibly strong storm, one of the strongest storms on record in the Atlantic Basin, and it got retired because it did quite a bit of damage in Mexico.
Yeah, we just, I forget which one, just a couple of years ago, we had our first major hurricane landfall since Wilma in the U.S. Was it Michael that broke the streak? Or was it? Okay, so in the U.S., let me see. In the U.S., the first major hurricane would have been Harvey. After right? Yeah, I knew it was a long streak.
And then shortly thereafter by Irma, and we went from having a really good streak of really good luck. We went 11 years with no major hurricanes to having a streak of really bad luck very shortly thereafter with Harvey, and then Irma hitting the continental U.S. and then obviously Maria devastating Puerto Rico. But yeah, in addition to Wilma's significant impacts in Mexico, it did make landfall along the southwest coast of Florida in a very similar location to where Irma made landfall and caused quite a bit of damage. It didn't get as much media attention as I think it otherwise would have, just given the fact that there have been so many hurricanes that year, after Katrina and then Rita, that by the time we got to Wilma, I think the media attention had shifted to other things, so it didn't get as much attention as I think it otherwise would have gotten.
We did have one late question roll in, Phil, from Shelley and Robbie Hunter. Which areas are projected to experience most of the activity?
Yeah, and so that, unfortunately, we can't say, okay, this year it's going to be a specific state or whatever, but overall, the large-scale conditions do look like they're going to probably be more conducive in the deep tropics this year than they have the past couple of years. So last year, we had a lot of hurricane activity, but we had Dorian, which came out of the deep tropics, and then a lot of the other stuff was at a little bit higher latitudes, and especially 2018, we had a lot of higher latitude storms. But this year, it looks like overall conditions in the deep tropics are likely to be more conducive. So I would expect to see more systems likely developing, say, off the coast of Africa in kind of what we call the main development region. So the eastern and central tropical Atlantic is where a lot of these really nasty hurricanes get spun up and get started.
We might have gotten the question ball rolling, so I know I'm not going to keep you much longer, I promise. Why do the hurricanes always come from the coast of Africa, comes in from Amy?
Okay, so hurricanes, they don't have to. Not every single hurricane comes from something that comes off the coast of Africa, but basically there's about 60 to 70 of what's known as easterly waves. So these are basically groups of thunderstorms that develop actually over the Ethiopian highlands, and they move from east to west across the Atlantic basin with the trade winds, which are the winds that basically blew the ships over to the New World back in the 1500s. And so basically you have about 60 to 70 of these every year, and thankfully most of them just go along across the Atlantic through the Caribbean and thankfully don't develop. But if other conditions are right, like I mentioned before, when you have low shear and when you have warm water, you can get something that will develop into a hurricane. But you do get storms in the Atlantic that form from other processes as well. You can get systems that develop. Basically, you can get fronts that come out of the mid-latitudes into the tropics. And if they get over warm water, sometimes they can develop and spin up and become tropical cyclones. But a lot of the really significant nasty hurricanes, like Irma and Maria, and even things like Michael that developed, even if it was in the Western Caribbean, it originated from a wave that came off of Africa, and then you can have interactions between several different systems that can then spin these storms up. So it's basically because those are kind of the seeds, or basically kind of where these hurricanes tend to germinate, is from these waves moving off the west coast of Africa.
So here in Louisiana, we had one of the unique examples last year with Barry. Barry originated from sort of an upper air disturbance up in the Midwest that dropped down into the Gulf of Mexico and gradually became tropical. So yeah, to your point, it's not always off of Africa.
Correct. Yeah, and Barry's a great example. It was a weird hybrid system that never looked, even when it was a hurricane, it never looked kind of like you would expect a normal hurricane to look, and that's because it had its originations it originated in the mid-latitude, so it became tropical, but it still had it still never really kind of looked purely tropical even when it was a hurricane. It takes a while for these systems to kind of transition over, and so since it made landfall fairly quickly, it still kind of had some. It was not what you would normally expect to see what a hurricane looks like. It was kind of had some of those frontal characteristics hadn't quite gotten completely eradicated yet.
All right, so one last question, and this is one I know you can't. We've kind of touched on this, but some people have come in late. So it's back to what I told you, what everybody wants to know. I've got somebody saying, what is Louisiana's hurricane season looking like? Talk about that again, maybe what you can and can't forecast.
Yeah, so when we do our seasonal forecast, we forecast for the Atlantic basin as a whole. And that's because once you start to subset the basin into smaller regions, we lose the ability to predict hurricane activity, especially as you move into higher latitudes. So say in the Gulf of Mexico and the subtropics, decreases. And that's because when storms, especially once they get into the Gulf of Mexico, you have some storms, as we discussed just a minute ago, that come from waves off of the coast of Africa. And those are what we tend to have the highest level of predictability for, and that's generally where most of the nasty hurricane activity comes from. But in the Gulf, you also have, as we just talked about with storms like Barry, that basically come out of fronts that move out of the mid-latitudes into the tropics. And sometimes they're kind of more like these hybrid where you get the wave combining with a front. And so basically overall, we find that our predictability scale is higher in the deep tropics. So I would say overall, it does look like the tropics are going to be more conducive this year for storm formation. But we can't say, exactly how active Louisiana particularly is going to be. But certainly overall, the season is above normal. And again, with all of our seasonal forecasts, we just emphasize that we need to be prepared the same every hurricane season because, it just takes that one storm making landfall near you to make it an active season.
All right, Phil, as promised, I'm going to let you go, but I can't thank you enough. I think everybody enjoyed this. I told you about 30 minutes. We're closer to 45, so I really appreciate you giving up this much time. I know you've got a lot to do.
Sounds good. Thanks so much. Take care.
All right. And Phil, I'm going to wrap up here. I'm going to tell people about what we're doing on Friday. You're welcome to hang on the line. You're welcome to hang up, whatever you need to do. Okay?
Okay. Sounds good. Thank you.
All right. Thanks again. All right, friends, so hope you enjoyed that from Dr. Phil Klossbach from Colorado State University, giving us kind of a detailed look at the seasonal forecast for this year and how they make those seasonal forecasts. Pretty interesting, and the guy he studied under, Dr. Gray, a real tropical weather legend. So let me mention one other thing about Phil real quick. Just a genuinely good guy. He helped me a good bit with my dissertation research that I did in grad school. I'd reached out to him, ended up helping me a lot with the methods, and every time I reach out to him, he always replies, and replies pretty quickly. We're working on getting some of my graduate research published together. He's agreed to come on as a co-author, so really appreciate him. All right, so here's what we're thinking about next for Friday. So I mentioned this before, but I think on Friday what I'm going to do, especially we'll get this, some of these topics are maybe hitting a little older audience. I want to get back to stuff that maybe some of the younger kids can learn from. So on Friday, I'm going to focus on weather satellites, but I'm not going to really get deep into how weather satellites work. We'll touch on that for a second. What I want the kids to see, though, is what I'm going to try to do is we're just going to make this kind of a cool slideshow of all the cool things we can see with weather satellites. I'm going to show you some of my favorite hurricane images, but we can see things like volcanoes. We can see yesterday, the National Weather Service in Jackson, Mississippi, they spotted on a visible satellite essentially a scar in the landscape in Mississippi from the huge tornado that rolled through on Easter Sunday. I actually spotted a couple of those. I'm going to show you some of the neat things we can see. So we'll do that Friday at 1 o'clock, and then going forward, we will see. I do have a storm chaser that is kind of given a tentative yes to coming on and doing one of these sessions. This is probably the busiest time of year for storm chasers, so we haven't set a date for that yet, but hopefully that'll work out. I think that'll be a little different. I know I've gone hurricane heavy, but that's what really sparked my initial interest in weather. It's probably still my greatest interest is hurricanes and tropical weather, so that's why I've kind of leaned heavy on that subject. But we'll get a storm chaser on hopefully, and we can talk a little more about severe weather and tornadoes, things like that. But as I said, Friday we'll talk. We'll really do more of hopefully kind of a cool picture show, some of the neat things you can see with weather satellites. So thanks again, everybody, for joining me today here on Cap's Corner. We will be back Friday at 1 o'clock. A little bit of a news note. Excuse me. I'm talking too much. We have a 4 o'clock newscast now here at Channel 9. Today, though, Governor Edwards expected to hold a press conference at 4 o'clock. So we'll have that live on air. If they're running a little late, we might start the newscast and then pick it up as soon as he starts. But what's maybe of added interest today is that there's some potential Governor Edwards might address more about the remainder of the school year today in today's press conference. So look for that coming up at 4 o'clock, and then I'll be back on air at 5 o'clock. Hope to see you then. Have a great day, folks.